Are the estrogens in dairy disrupting your hormones? Given that dairy is a centerpiece of the pro-metabolic sphere, I think it'd be helpful to provide some nuance to the topic of dairy. So in this video, I'm going to first discuss what I typically see with my one-on-one clients and individuals inside my program in terms of their responses to dairy. Second, I'm going to show some research showing that dairy can directly impact the hormones of humans. And third, I'm going to provide solutions for you and workarounds if you find that dairy has a negative impact on your hormones. Now, before we jump in, if you'd like to work with me directly to troubleshoot your dairy tolerance and or optimize your hormones, I just reopened a limited number of new spots in my exclusive coaching program. In the program, you'll be able to speak with me directly 7 days per week to get personalized guidance to rebuild your health. So if you're interested, go to mikefave.com to grab your spot now. Now, after working with hundreds of people using a pro-metabolic approach, I have found that the tolerance to dairy is often the exception, not the rule. And one of the major concerns that I have found with people is that they don't seem to tolerate the hormonal component of dairy. So typical symptoms that I will see will be issues with weight. So that's either weight gain or weight loss resistance, where it's actually difficult to lose the weight. The next one is I see people holding onto water. So typically see water weight gain, like swelling, things like this, being puffier in general. Another one is acne. And quite a few clients that I've worked with, dairy is a huge trigger for acne. Another one is hair loss. I've seen a couple of guys who introduced dairy, including myself, and it seemed to actually speed up the hair loss process. Now, there isn't a direct research study on this, but this is, again, just anecdotal experience and experience from working with clients. Another one is gynecomastia. There's quite a few men I've worked with who developed a bit of gyno or fatty development around the breast tissue when they started to incorporate large amounts of dairy into their diet. Another one is for women, changes to their cycle. So they have PMS symptoms worsening when they start to incorporate dairy, or the cycle length starts to adjust. And then the other one we see is changes in libido. This is a big one. So this is not only related to the hormonal component of dairy, it can also be related to the casein component and the casomorphin peptide that we find in casein. But in general, I tend to see with some people that dairy seems to have a negative impact on their libido. Now, this doesn't happen to everyone. Some people actually seem to tolerate dairy just fine and do not have these issues. So the goal of this video is not to trash dairy and say that dairy is a bad food and that you should not have it. The goal is to provide some nuance and some perspective so people who are having issues with dairy can try to determine, is the hormonal component a problem for them, and then what they can do instead. All right, so now what I want to do is I want to jump into some of the research that lends some support to the idea that dairy can actually be problematic for the hormonal profile. And so what we see, and this is from a paper titled Exposure to Exogenous Estrogen Through the Intake of Commercial Milk Produced from Pregnant Cows. So what the research talk about in this paper is that the cows that are typically used for dairying at this point are pregnant for a large portion of the year. They say about 305 days, and I'll read the quotes in just a second. And when the cows are pregnant, they are producing high amounts of hormones like estradiol or different estrogens, as well as progesterone. And that can actually wind up inside the milk. And then when humans drink that milk, it can have an impact on our own hormonal profile. So the researchers wanted to actually set out and see if this occurs in humans. But they preface this argument, or they preface their paper this way. They say, modern genetically improved dairy cows, such as the Holstein, continue to lactate throughout almost the entire pregnancy, extending the milk producing period to 305 days per year. Therefore, recent commercial cow's milk contains large amounts of estrogens and progesterone. They say milk is considered to be a rich source of estrogens. Indeed, estradiol concentration is higher in mammary drainage than the peripheral circulation in high-yielding cows. They say pregnant cows under the control of relatively high levels of estrogens and milk produced from pregnant cows contains correspondingly high concentrations of estrogens. Estrogen concentration in milk has been measured since the 1970s, mainly as an indicator of pregnancy. They say concentrations of estrone sulfate increases from 30 picograms per milliliter in non-pregnant cows to 151 picograms per milliliter in pregnant cows at 40 to 60 days of gestation, and to a maximum level of 1,000 picograms per milliliter in cows at 220 days of gestation. So essentially, when the cows are pregnant, the cows have been basically bred so that they will produce milk throughout their pregnancy. And when they are pregnant, they have a high concentration of circulating estrogen, so estradiol, estrone, and also progestogens that can actually wind up in their milk. And so that's what the authors are saying here. They further go on to say, recently, according to Malekinajad et al., the concentration of estrogens in cow's milk under various conditions was measured using liquid chromatography tandem mass spectrometry after enzymatic deconjugation. The results indicate that processed milk with 3.5% fat contains high concentrations of estrone and estradiol. Kin et al. Also reported high concentrations of estrogen in pregnant cow's milk. Moreover, milk and milk products containing high amounts of progesterone, which can accumulate with increasing milk fat content. So again, what we're seeing is there's authors who have actually looked at the estrogen content and progesterone content of milk and have found that those hormones are indeed present. And so the question now is, does this actually affect human hormones? And so that's what we're going to look at now with this paper. The authors, they basically took men, women, and children, and they gave them 600 milliliters of cow's milk, and then they checked their hormones at multiple different time frames. So they say subjects were 7 men, 6 prepubertal children, and 5 women. The men and children drank 600 milliliters of cow milk. Urine samples were collected 1 hour before the milk intake and 4 times every hour after the intake. In men, the serum samples, so the blood samples, were obtained before and 15, 30, 45, 60, 90, and 120 minutes after milk intake. When the women and children and the men, they collected urine samples, and in the men, they further did blood sampling at multiple intervals before and after the men drank the milk. And so what were the results? They say here, in the present study in men, concentrations of serum estrone, a type of estrogen, and progesterone increased after intakes of cow's milk. Concentrations of serum LH, FSH, and testosterone significantly decreased 2 hours after intake, and the volume of urine excretion of estrone, estradiol, and estriol significantly increased. So basically, those last 3 are all different types of estrogen. So serum estrogen and progesterone levels in men drinking milk increased after consumption of milk, whereas testosterone, LH, and FSH decreased. And then in the urine, we saw an increase in estrogens after the consumption of milk. So we're seeing that we are actually seeing a change in the blood levels of hormones, essentially in response to the consumption of dairy in this study. They go on to further say, these results suggest that estrogens in milk were absorbed, and gonadotropin secretion was suppressed, followed by a decrease in testosterone secretion. So basically, when they took in estrogens and progesterones, it caused a lowering of LH and FSH, which are the hormones that come from the brain and act on the testicles to tell the testicles to produce testosterone. And then testosterone levels were subsequently reduced as well. They say the activation of a negative feedback mechanism due to exogenous estrogens in cow's milk indicates that men are affected by intake of commercial cow's milk. Because the main estrogen in milk is estrone, and estradiol concentration is relatively low compared to estrone, serum estradiol levels do not change for 2 hours after the intake, but instead urine excretion of estradiol significantly increases, suggesting that the conversion from estrone to estradiol progresses slowly. So essentially what they're saying is that milk contains estrone, which is a type of estrogen that's a bit different than estradiol. And what happens is when men drink the milk, estrone increases and the body can convert that estrone into estradiol, which you see in the urine. So it's not necessarily estradiol that's being bumped up by the milk consumption. It's more the estrone, which is metabolized then into the estradiol. Then they say for all adults, so for all the women and children, they say urine concentrations of estrone, estradiol, estriol, and pregnanediol significantly increase in all adults and children. So even in the women and children outside of the men, you're actually seeing a change in the urine concentration of these hormones. So we actually have some graphs here to look at. And what you can see, this is in the men. So in figure A here, we're looking at serum estrone concentrations. Figure B here, we're looking at estradiol. And figure C here, we're looking at progesterone. And so what you see here is, here's basal before milk, and then here's the peak concentration that they achieved after drinking milk for estrone. And it's actually significant. And the same thing for progesterone, it's significant. The basal value of progesterone is significantly lower than the peak value after drinking milk, whereas estradiol actually didn't change significantly, even though we did see an average increase. Then when we look at serum luteinizing hormone, serum follicle stimulating hormone, and serum testosterone, we see that luteinizing hormone decreases significantly, follicle stimulating hormone decreases significantly, and then testosterone decreases significantly. So we're looking at about just above 600 nanograms per deciliter of testosterone, go down to roughly below 500 nanograms per deciliter after drinking the milk. It's about a 100-point drop. And then when we look here, we look at the urinary excretion. So we see the basal level, the before drinking milk excretion of estrone and then after, we see a significant jump. So we're around 500 before, and then after we're up at 800. So almost a 2 times increase, a little bit less than a 2 times increase in the urinary estrone levels. Then here we see the estradiol levels. We're at 150 to start before the milk consumption, and then after milk consumption, we see about 250. If we look over here, we see the estriol. We're about 20 to start, and after milk consumption, it goes up to about 80. And then if we look over here, we see pregnanediol, and we see the levels are probably around 12, and then they go a little bit potentially to 16 after the consumption of dairy or milk in this circumstance. So basically what we're seeing is in the blood, changes in the estrogen levels, and in the urine, we're seeing changes in estrogen levels as well. Given that we see that dairy products can impact the hormones, the question is, what can you do about this if you're somebody who experiences some of the symptoms that I mentioned previously in response to dairy? Well, most of the hormone components of dairy are typically concentrated in the fatty portions of the dairy, so in the dairy fat specifically. So if you're having problems with tolerating dairy and you think it's specifically related to the hormones, not to lactose or casein, which I will cover in other videos, then you may want to minimize your high fat dairy sources. So there's going to be things like cream, butter, ghee, fatty cheeses, fatty yogurts, ice cream, etc. So you're going to want to kind of put those to the side, because if you lower the lipid portion of dairy, you'll have less, or ideally less, estrogenic exposure. Now, what you can use instead would be lower fat dairy options like whey protein, casein protein. You can use low fat yogurts, and you can use low fat cheeses, which would decrease the amount of exposure to hormones, particularly the fat soluble hormones like estrogens and progesterones from the dairy, because they are typically in the fatty fraction, the lipid fraction of the dairy. And then even with this, if you don't tolerate casein, which casein itself can have an impact on your hormones, and I have another video about this, which I will link in the description below, then you may want to shift just towards whey protein consumption. The casein contains a peptide called beta-casomorphin 7 that has opiate signaling properties that can affect prolactin and dopamine balance that could further impact your hormonal profile. So in that circumstance, you'll want to shift just towards whey. So those are the tiers that I typically work through when I'm working with clients or when I'm working with people inside my program to help them figure out where they fall on the dairy spectrum. It's not that you have to completely eliminate dairy. It's not that dairy is this terrible food. It's that some people don't respond well to the hormones in dairy. And then in that circumstance, they're going to have to adjust. And this is how you can go about adjusting. So we have some evidence here to show that drinking milk can indeed impact the hormonal profile in men and also children and women. So given this, while hormones present in dairy are one of the major concerns with dairy, there are other components in dairy that may be leading to a dairy intolerance. And I discuss those other problems in videos here.